Good morning, everyone, and welcome to this lecture. This is lecture number 11 in collision, and we are dealing with impact. In the last lecture, we had seen what is a collision. A collision is nothing but it is an interaction between two bodies, and the momentum of the bodies change. It's the redistribution of momentum of the bodies. Whenever we are talking about collision, we are talking about an event where large forces, impulsive forces, are going to act on the body, and the momentum of the bodies are going to change drastically. Do you remember this? Yes or no? We had seen that collisions can be classified into different ways. They can be classified on the basis of the line of impact. What is line of impact? Line of impact, anyone? What is the line of impact?
And along which impact happens.
That is a line along which impulsive forces act. Impulsive forces act along that line, and momentum of the bodies will change along the line of impact. And this line of impact is normally is 99% the common normal, or you can find it out by the change in momentum. And we have seen on the basis of line of impact, we can classify the collision as central or eccentric. In central collision, the center of mass of the two bodies lie along the line of impact. This is the type of collision, central collision, that we are going to deal in this chapter. The other type of collision where the line of impact does not pass through the center of mass, we will deal in the chapter on rotation. Then we had seen what is a direct collision, a head-on collision, 1D collision, or an oblique collision. Everyone remembers the examples also. The head-on collision, oblique collision. These three examples that I have shown. Yes or no? Okay. You have taken a lot of steps forward. Now, the third type of collision that we are, next thing that we are going to study here is coefficient of restitution. So we'll write the next heading, coefficient of restitution. Listen to me very carefully, and then you will write. Now, what is this coefficient of restitution? I don't think you would have heard this word. Now, how do we understand this coefficient of restitution? Now, to understand this coefficient of restitution, let us have a look at what happens during a collision by a quick snapshot of what is happening during a collision. Now, these are three snapshots of the two bodies taken during a collision or impact. On the left hand side, you can see the snapshot taken before collision. Do you see this? Two balls are moving, M2 and M1. Here you must understand that this U2 is less than U1. So the ball which is ahead is moving slowly and the ball which is behind is moving faster. So what is going to happen? The faster ball is going to impact the slower ball. You understand this? The third snapshot The third snapshot is the snapshot taken just after the collision where the balls have separated, and now you can understand that this V1 will be less than V2. The ball which is ahead will be moving faster compared to the ball which has impacted it from behind. Do we understand this? Now, how this impact happened? We can clearly see three different stages. One is before collision, one is during collision, and one is after collision. Three different snapshots. Now, what is happening when the ball is colliding? The two balls are coming in contact. The two balls are coming in contact, and what happens is once they come in contact, they start to get deformed. Their shape starts to change. We don't see that change in shape. We can even see that if you are hitting a football which has got very not much air, and which you hit that football with your toe or legs, you can see the football get deformed. If you are playing with a tennis ball, you're playing cricket with a tennis ball and you hit the tennis ball with your bat, you can see actually the tennis ball gets a bit deformed when it comes in contact with the bat. So when the bodies are colliding or having an impact, when they come in contact, what happens is instantly do not instantly they do not go away from each other. They will remain in contact for a very short interval of time. That interval of time is given by delta t. This delta t is the interval of collision. This delta t, that time you see, is where this entire two balls are in contact and they are getting deformed. So what happens? The balls get deformed and they keep on getting deformed until a stage comes when the two balls are in their maximum deformed state. And this is the stage up till here. At this point, the balls are in their maximum deformed state. Do we understand it? They keep on deforming. They keep on deforming, they keep on changing their shape, and the ball come to their maximum deformation at this point. Now, up till this point, what was happening was U1 was less and U2 was more. This ball is going ahead, this ball was hitting it from behind. So what is happening is this ball which is behind is giving it impulse in the forward direction, and the ball which is ahead is giving it impulse in the backward direction. Please listen to me, then you can write. Do we understand this? The two balls are applying forces or impulsive forces on each other, equal and opposite. On ball 1, the impulsive force will be, or impulse would be, in the backward direction. On ball 2, the same impulse would be on the forward direction. We call it ID, impulse of deformation. Do you understand why we call it impulse of deformation? Because this impulse is going to deform the body. This is known as impulse of deformation. Impulse of deformation. Now, because of this impulse of deformation, it is in the opposite direction. The value of U2 will keep on decreasing and the value of U1 will keep on increasing. Do we understand this? At this point, both of them, they are in maximum deformed state and they are moving with the same velocity v. They are moving with the same velocity v. So at maximum deformed state, they are moving with the same velocity. This stage, this part of the spectrum, this yellow part The bodies are getting deformed, and this is known as the stage of deformation. Bodies are getting deformed, and at the end of this stage, maximum deformation, the bodies are moving, the bodies are moving with the same velocities. Do we understand this? Now, what happens after this stage? The body are still in contact. They cannot just leave it like this. So slowly, slowly, they will try to come back to their original shape. Do you understand this? Slowly, slowly, they will try to come back to their original shape. Do you understand this? They are still in contact. They are trying to come back to their original shape. The impulse is still in the same direction. This impulse on this ball is in this direction. The impulse on this ball is also in this direction. But this impulse, what it is doing now, it is trying to reform the body. And this impulse is known as the impulse of reformation, IR, which is trying to reform the bodies, which is trying to bring the bodies back to their original shape. So after this line, what happens? The bodies start to come back to their original shape, and at one point in time, what will happen? They will leave the contact, and the two bodies will start to move with different velocities. V1, the final velocity of the first ball, will be less than V2, which is the final velocity of the second ball. Do we understand this? So this has gone above our heads saying bye bye. Do we understand this? Yes
Sir.
or no?
Oh, sir.
Now, if we talk about the values of this impulse of deformation and the values of this impulse of reformation, you can write it in many ways. This impulse of deformation, impulse is change in momentum. Yes or no? No, yes. This impulse of deformation is final momentum minus initial momentum. So you can write it as m1 into v minus u1, change in momentum of first body. This will come negative because the impulse is in the backward direction. This can also be written as m2 into v minus u2. Do we understand this? Do you understand this? Impulse of reformation. Final momentum minus initial momentum. m1 into v1 minus v, that will be equal to m2 into v2 minus v. Do we understand this? Yes or no? Now, if you see the two equations, you can equate the two equations, and from there you will land up with this revolutionary result. What revolutionary result you will get? Now remember, this impulse of deformation vectorly on one body is in the reverse direction, on body 1 it is in the backward direction, and on body 2 it is in the forward direction. So what I should do, if I am just talking about the magnitudes, I must write this as minus and I must write this as minus. Do you understand this? Why I have written this? Because this impulse is in the backward direction, it will come negative. I am talking about the magnitudes here. We understand this? Yes or no?
Yes, sir.
Now if I solve these two equations, you know what will I get? I will get V is m1 u1 plus m2 u2 divided by m1 plus m2. This v is the velocity which it moves together, the ball moves together, and that will be equal to m1 v1 plus m2 v2 upon m1 plus m2. This, my dear friends, is basically the velocity of the center of mass before collision, and this is the velocity of center of mass after collision. That tells us that the momentum of the center of mass remains constant. Do we understand this? This is velocity of center of mass before collision. Yes or no? And this is the velocity of center of mass after collision. And from here we see that nothing is happening, but what is happening is momentum is getting momentum is getting redistributed. No one is going to ask you impulse of deformation and impulse of deformation. This is just for your JEE advance. If a question comes, you need to know it. What we were discussing was something known as the coefficient of restitution. Now, what is this coefficient of restitution? This coefficient of restitution is nothing but ID divided by IR. IR divided by ID. Impulse of reformation divided by the impulse of deformation. That's it. Impulse of reformation divided by the impulse of deformation. Now, if I put the values of impulse of deformation and if I put the values of impulse of reformation in terms of V1, V2 and U1, U2, we will get this one. V2 minus V1 upon U1 minus U2. This is the value that you will get. Now V2 minus V1 is velocity of separation. Do we remember we had seen this velocity of separation? Divided by velocity of approach. This is what you need to remember. Impulse of deformation and impulse of reformation are only for your academic purposes. They will only come, any question on this will only come in JEE Advanced. I have not seen a question till now, but you never know. But E can definitely come. Many questions on E has come. Have you understood the value of E? Everyone? Now I'll give you 2 minutes. Take a deep breath, draw the diagram, and write. If you have any doubts, please ask. Then let's move ahead and see the next type of collision. And the next type of collision is based on the conservation of energy, on the basis of energy. And how do we classify collisions on the basis of energy? On the basis of energy, the first type of collision is known as perfectly elastic collision. Some people call it simply elastic collision. So whenever you hear the term elastic collision basically means that it is a perfectly elastic collision and nothing else. A perfectly elastic collision. Now, can anyone tell me what would be a perfectly elastic collision? What are the points that you must remember about a perfectly elastic collision? Yes. Anyone has any perfectly elastic collision? Yes.
The collision which conserve momentum and kinetic energy.
Momentum and kinetic energy. What happens to momentum and
Are
kinetic
conserved.
Momentum and kinetic energy are conserved. Okay, elastic. You never define the term elastic. What do you mean by the term elastic? The name of the collision never says kinetic energy conserved collision. Energy conserved collision. It never says that. It says perfectly elastic collision. Where is the term elastic? It never says momentum conservation collision. Momentum is conserved, so momentum conservation collision. The name is perfectly elastic. It has got nothing in that meaning that energy term never comes. Perfectly elastic. Have you heard the term elastic? What do you mean by the term elastic?
Which is stretchable.
Which is extensible. Think again. Which is extensible. What happens after it is extensible? After you extend it, what happens?
Its size increases.
After its size increases and then you leave it, then what happens? We call something as elastic. What does that mean? It means that if you change the size or shape, it will come back to its original size or shape. That is the meaning of the term elastic. What is a perfectly elastic collision? If during collision, what happens? We have just seen during collision, what happens when the body come in contact? What happens? They start to get what? Just now we saw it.
Collides.
When the bodies collide, does anything happen? What happens when they are colliding? What happens when they are colliding? Something happens to their size, shape, or nothing happens? Just now we have seen it
Deformation.
2 minutes. 2 minutes before we have seen it. Yes, what happens?
Deformation.
Deformation happens. Their size and shape change. If the colliding bodies regain their size and shape completely after collision, then that collision is known as a perfectly elastic collision. That is the meaning of the term elastic, and this is a perfectly elastic collision. This is a perfectly elastic collision. No fraction of mechanical energy. You have remember the term mechanical energy. No fraction of mechanical energy is stored as deformation. The bodies are going to get reformed. So no part of mechanical energy is stored as deformed potential energy. When the bodies get deformed, energy gets stored in that form of deformation. Since no part of mechanical energy gets converted into or stored as potential energy, the kinetic energy of the system kinetic energy of the system remains constant. What do you mean by kinetic energy of the system remaining constant? Kinetic energy, final kinetic energy will be equal to the initial kinetic energy of the two bodies. Remember, their individual kinetic energies will change, but the sum total will remain same. Kinetic energy of the body or the system remains constant. The momentum of the system remains constant. We have just seen that. Momentum of the system remains constant. Momentum will always remain constant. P final is equal to P initial. What next? The bodies are completely going to reform. Therefore, ID is equal to IR. What do you mean by ID is equal to IR? What do you mean by ID is equal to IR?
Impulse of deformation is equals to impulse of reformation.
Impulse of deformation is equal to the impulse of reformation. I can write the same thing in a different way. The value of E will be equal to
One, sir.
yes, the value of E will be equal to 1, sir. The value of E will be equal to 1, sir. Or I can say, since I don't have space, so I will write it. Okay. I can use the space by scrolling down. So I can say this in another way. V2 minus V1 will be equal to U1 minus U2. Velocity of separation will be same as velocity of approach. Do we understand this? This is a perfectly elastic collision. These are the points you must remember. Remember, we have said that the momentum of the system and the kinetic energy of the system remains constant. That does not mean that the momentum and the kinetic energy of the bodies remain same. The momentum and the kinetic energies of the bodies have to change. It's the kinetic energy and momentum of the system that remains constant. Do we understand this? I'll give you 2 minutes now to note it down. One more thing you must note here. This value of E that we have written, this velocity of separation and velocity of approach, you have to find it along LOI, the line of impact. The value of E, in direct collision, it will be along one direction only, everything will be along one direction. But in oblique collision, this velocity of separation and velocity of approach, this formula or the value of E can only be applied along the line of impact, because it is along the line of impact that the reformation and deformation impulses act. So I forgot to mention it. So remember, the value of E is always applied along the line of impact. So velocity of separation and velocity of approach is along the line of impact. So you can mention it here also. V2 minus V1 is equal to U1 minus U2 along the LOI. LOI means the line of impact. So just keep this in your head. Okay, now note it down. This was perfectly elastic collision. Now you must remember a perfectly elastic collision. It is not possible. You cannot have a collision which is perfectly elastic. In collision, whatever you do, no matter how elastic balls you produce, there would be some deformation which is always left in those balls or material. You cannot create a perfectly elastic collision. It is impossible to have a perfectly elastic collision. It only exists in theory. Whenever you say something perfect, perfection is only in theories. So perfectly elastic collision is basically not possible. Then we move on to the next type of collision. What is the next type of collision? The next type of collision, collision number B, is known as perfectly what? Inelastic collision. Some people also call it plastic collision. Since it is perfect and perfection is impossible, so again this type of collision is actually not possible in day-to-day life. So again a theoretical concept. What will be a perfectly inelastic collision? Now, this is the exact opposite of a perfectly elastic collision. So, in perfectly elastic collision, both the colliding bodies completely regain their shape. In a perfectly inelastic collision, the colliding bodies do not regain their shape at all. They do not regain their shape at all, and they remain in maximum deformed state. Do you remember that maximum deformed state? This is their maximum deformed state. This is their maximum deformed state when they are moving together. This is their maximum deformed state when they are moving together. So they remain like this. They remain in the maximum deformed state. They remain in the maximum deformed state. Do we understand this? They remain in maximum deformed state. Then what happens? The kinetic energy of the system changes. In fact, the kinetic energy of the system will decrease as some Ke is stored as potential energy in the bodies. In fact, the loss in kinetic energy is maximum. Loss in kinetic energy is maximum in case of in case of in case of perfectly inelastic collision. But the momentum of the system remains constant still. Remains constant still. That means The initial momentum and the final momentum remain same. The loss in kinetic energy is maximum. Momentum remains same. Now I can say the same thing in terms of impulse. Here the impulse of reformation will be equal to how much? Reformation impulse is the impulse which tries to bring them back to their original shape. What will be the value of IR here? The value of IR would be 0. There is no impulse of reformation. Since there is no impulse of reformation, the body will not recover their shape and they will remain in their maximum deformed state. Can you tell me what will be the value of E?
Zero.
The value of E would be 0, my dear friend. 0, 0, 0, 0, 0. The value of E would be 0. The value of E is 0. We can also say this in a different way. The value of E is 0. The value of E is 0. Look at the value of E. So you will get V1 is equal to V2. V1 will be equal to V2 along the line of impact. Along the line of impact, they will have the same velocity. Along the line of impact, they will have the same velocity. If the collision is 1D, if the collision is 1D, 1D means head-on, then both bodies will move together. If the collision is 1D, then both bodies move together. You can see it here. If it is a perfectly inelastic collision, if it is a perfectly inelastic collision, both the bodies will remain in their maximum deformed state and they are moving with the velocity v, which is the velocity of the center of mass. Do we see this? So they will keep on moving together with the same velocity, which is the velocity of the center of mass. Do we understand this, or this has gone above our head saying bye bye? Bye bye. Have you understood this?
Sir.
I'll give you 2 minutes to note it down. Once you have noted it down, please let me know so that I can move ahead in life. So let's move ahead. A perfectly elastic collision E is 1, not possible. A perfectly inelastic collision E is equal to 0, not possible. Then what is possible? What is possible then? Somewhere in between it is possible. That type of collision is the collision that we see in day-to-day life that is known as inelastic collision. It is not perfectly inelastic. Inelastic collision. It is in between things, both of them. Bodies regain their size and shape partially, not completely. They regain their original size and original shape partially. So there is some deformation which is left. Part of kinetic energy is converted into potential energy, deformation potential energy, kinetic energy of the system changes. In fact, it will always decrease. But momentum of the system remains constant. That means, oops, that means PF is equal to PI. What can we say about the impulse of deformation and impulse of reformation? Impulse of reformation is less than the impulse of deformation. So it cannot regain the shape completely. It does it only partly because this impulse of reformation is less than the impulse of deformation. What can you say about the value of E? Can anyone tell me what will be the value of E for this case? Or in what range the value of E will lie? Anyone? The value of E will lie between 0 and 1. The value of E will lie between 0 and 1. And if we talk about the velocity of separation, the velocity of separation will be less than the velocity of approach. Remember, this is always applied along the line of impact. This is the type of collision which is possible and which we see in our day-to-day life. I'll give you 2 minutes to note it down, please. Well, then this brings us to an end for this class. In this class, what we have seen is the classification of collisions, and we had seen what remains constant and what changes. What we have seen is the momentum of the system will always remain constant. Is the kinetic energy that may change. It is the value of E that changes, but the momentum of the system will remain constant. In the next class, please come prepared because we will be now attacking some problems and seeing how we have read the theory part. Now we'll have to apply it, and we will start with 1D collisions, and we will see how we can apply all this that we have read into 1D collisions and see its effect. So I will wind up this class here, and I'll see you tomorrow. And tomorrow probably we should be able to wind up major part of this collision chapter. So I'll see you in the next class. Take care. God bless all of you. If there's anything, any doubt, please let me know.